Good morning, everyone. Now I understand the breadth and width of the audience. All right. So one of the most important things of doing a good presentation is to know your audience. And now you can see the challenge I have. Some people are, what Nirmala mentioned, she's looking at data science. Although I am going to cover a little bit about data science, it's more of a fun-loving, playful way. It's not a very serious approach. I just want the audience to enjoy being able to do some predictions and stuff like that. Anyway, but you were talking about evaluating the results. That one is a bit more serious, involved kind of thing. But you can always send me an email if you have any questions. All right. So again, thank you very much for joining the second class. I just want to tell you a little bit about the assignments. Okay. It's true in life. People never teach you everything, but then they ask you some questions to expect you to know. Don't think it's being unfair. That's the way the world is. All right. Now, some of the things that were in the assignment wasn't really taught in the class, but you needed to actually try it out and think for yourself, and then get hooked onto it. All right. That is the whole purpose of an assignment. Why we do that is because we want this Python knowledge to be yours, to be your own. That means you have taken initiative to learn it, to practice it, and to make it your own. So you don't have to say, oh, Mr. Kana taught me, or Sir taught me, or whatever. It is now your own. So in order for you to take ownership of this knowledge, you must at least attempt the assignment, so that in the next class, you can ask the questions. All right. So because I didn't teach you, I'm going to go through the assignments with you now, just like maybe 10 minutes. For those who haven't actually looked at it, let me share my screen. You must remember that even in your exam, I don't know whether you remember I mentioned to you that number 11 is actually an innovation. Only if you did your assignment of understanding 0 to 9 and the teacher taught you 10, then 11 becomes your invention. So it is very, very important to learn mathematics from a creative point of view, rather than beating yourself up and trying to memorize everything. That is not the way to go. All right. So for that purpose, even in programming, you need to internalize a lot of what is happening. Internalize a lot of what is happening. All right. So we went through variables, which is the fundamental building block of programming. Then we went on to talk about scalars, and we talked about arrays. Okay. And I didn't really focus too much on arrays on the assignment, because I didn't want the knowledge gap to be too far apart. But anyway, let's dive into the assignments. Okay. So I hope all of you have the link. If you don't have, raise your hands. The link for the GitHub account, and there is a icon right at the top that says open in colab. You can just click on open in colab, and you will get a new instance. If you already have saved it in your Google Drive, you can also open that, no issue. All right. So the first assignment was to create a string. Very simple, right? Just create S equal, you can type any string you want in here. So whenever I put the double quotes, it becomes a string. All right. So the string can be, how are you? It can be any string, right? You can put even a question mark. So that's the first line. Now print the second last to the start of the string. So for immediately, you need to understand that a string is actually an array. Okay, so you see what's happening right now is that it's connecting, it's actually creating a Linux operating system dedicated to your browser. It's initializing it. You can see right here, now it's connected, and then it's associated some RAM and disk space, and it's able to print it out. So this is one of the best tools I found. So now recording in. Yes. Okay, so I am going to continue. So now I've created my string. So you can see when I just type S, it prints it out. Then I am going to write some more code. Okay, so I'm going to just print out S1. Okay, I didn't teach this because I wanted you to understand that a string is actually an array. So you can see it's printed out 0 because 0 is the, it's not 0, it's O, because O is on the first spot. So let me type it again. So if I show you what is S0, okay, so there's a difference between 0 and O. So if you execute this, you'll find that it prints out H. So basically a string is an array, okay, and each alphabet is put in a particular location. So now one of the beauty about Python is that I can write code like this, S, and I can put a semicolon, and I can say start from 0 all the way to 3. And I do this. This is one of the most beautiful things about Python. You can actually write very powerful statements within that line. Let's say you wanted to capture all the house in the sentence. So you can actually do it like this. So, and you can even go on to write like this, S, you can do 0 colon -1. All right, and let's execute that. So when it goes to 0 to -1, it starts to come back. So you can see the original string had a question mark, but it omitted the question mark because -1 means come back 1. All right. So you can actually start playing around with this. So if I want to print out, the assignment is print the second last to the start of the string. So I just need the assignment answer is S0 -2, because now I can print everything up till that. Can you see how it works now? So it is actually a loop. All right. So this is how we manage arrays. So what you needed to do was actually type out the string. All right. And then you should realize that now this is actually an array pointer. It's pointing to the location 1 in the array. So just like how if I point it to 1, it's going to go to O. If I point it to 0, it's going to go to H. This is something you need to understand. The number, the way the computer counts, the first position is always 0. All right. Don't ask me why, but that's how it is. The first position is always 0 in an array. All right. Then the second position is only first. All right. I always wondered why it was like, the first runner-up of a beauty pageant, but she's actually second spot. The same thing, the same concept, here. The first position is always a 0. The second position is 1. So like that, we have total control. So, and when you go to -1, it's actually gone to the end and starts to come back. All right. And Python is so intelligent that I don't even have to put the first value. I can just do like this because it's assumed that the first value is always 0. So you can see I get the same answer even if I don't put a 0 in front. So that is why Python is so intelligent. So now I can quickly run back and forth between an array or a string and pick out certain words. And this is the power of Python. And believe me, to do this in Java is a bit, you need a few lines of code, you need to write a method, this and that. All that is now taken away because Python is easy for you to handle string messages. Okay, So that is the second one. Show the length of the string. Okay, this one I taught you guys. All right, so you just have to do code. Now just type length. So these are we call this control words like length, type. Don't ever name a variable called length because you'll get confused. Are you talking about the internal function within Python called length, or are you actually creating a new variable? So always good to keep it simple. So you just have to do that. All right, and you can get the length of the string. So if you were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is string, huh? 17, 18. Now, the unique thing about length is that it starts from 1. All right. So the length, and so when you there is a difference. When you count it, it starts from 1, but the position is 0. All right, so that is the important distance differentiation between position and location. Okay, so sorry, length, position and length, so that it's different. So it gives us the correct answer. Position 1 is actually the second spot, but the length is 18. So this is the third assignment. It's very simple, right? Now convert a string to an array. Use the type as shows. So this one is oh, what is that? Okay, so we've already done that. So let me just type. We can do x or equal list s. So here the type mismatch. So we can actually put we don't have to use list, and so now you see it's become array element by itself. So by putting in the square bracket, so I can do the same thing for so this is actually creating it into a list. Let me show you why is it a list. Because if I want to check, I can do type and then I put x. You can change it to, you can see the type now is type list. All right, so I can change the type from a string to an array, but a string is actually an array of alphabets. Okay, so that's how it's managed. So I hope that you understood what assignment 1 is all about. This is very, very rudimentary, but as we go further, it will get more exciting, because now we're going to look for specific words like what Nirmala Balakrishnan mentioned about data science and all of that. We want to be able to, let's say, detect fraud email, right? How we do that is actually we know certain keywords. Like say, I know this is a bit racist and not very correct, but when you say black money, you know, then you know that it's a fraud email, right? How do we do that is because we are able to pick up on certain words inside the email that says certain words, and then we can determine whether it's a spam email or not a spam email. All right, so in order to do this, we need a programming language to actually pick up on these words. So we're going to say, okay, now look for money, and what is the probability of that? And then we try to find out whether the probability is high enough for us to determine whether it's a spam email. So this is why we are learning this. So whenever there is a particular string that you want to search, you can actually use it in a very easy way to handle in Python. So I hope you understand how Python now handles variables. So it's intelligent enough to a very high degree to identify that this is a string, so therefore it's an array of alphabets. So what is it actually storing is the byte value of that alphabet. That's why it can convert it to any format, okay, for us humans to interact with the computer. Okay, so if you have any questions, you can send me your email, or you can ask the questions. I'm going to go on to the second lesson today. Okay, I hope all of you have the link. Okay, and today we will take a small break. Okay, what is that, before we actually start? And okay, so there are some questions coming here, so let me just. Okay, thank you. We are on the same page, Nirmala. Okay, can I have the link for the second lesson? Okay, sure. You see, if you go, okay, let me just show you right now. If you click on this master class right here, it takes you back to the main page. Okay, so in the main page, I have listed the first 5. Okay, I will keep adding as we go. You can see what are the lessons for the other classes, but just click it before I start the class. Like lesson 3, I'm still not completely finished with it. So as we come to the class, we will make it more relevant. So today you can click on lesson number 2, and it will open up your it'll open it up in your what is that, in your GitHub. All right, again. So let me begin by logical operators. Okay, you are free to try it out while even you're in the lesson. Okay, there's no hard and fast rule for you to follow any procedure. Okay, so now let's begin with lesson number 2. Now, since we understand how to store values, um, we need to build some intelligence. Okay, everybody is afraid about computers. Oh, the computers are getting very smart, but actually, what they are doing is replicating human uh, cognitive ways. Okay, so what do I mean by that? A logical operator is basically asking you to make a decision. This is a decision making process. That means, do I turn left? Yes or no? Do I turn right? Left or no? Remember when we were young, or when you were asked to cross the road, first look left and then look right and then look left again. So these are checks or processes that you go through. This is a process. Look left, then look right, and then look right, left again to see whether there's any car. If all those 3 checks tells you there is no car, then we cross the road. So it is a decision-making process. Now, how do computers do this? Is by using logical operators. Okay, I know it sounds very technical, but basically it's logic. Is it true or is it false? That's what we want to know when we do a logical operator. And there are many types of logical operators. All right. We will go through quite a few of logical operators, and then towards the end, I have some for loops, but I didn't focus much on the loops, because we will continue that in the next lesson. It's easier to see the for loops in action rather than to kind of understand what a for loop is. So let's look at what logical operators do. Now, what we want to achieve is to come up with a process. All right, a process means, if I take A, if I take B, and I add C, then I will get chicken curry. That's a process. So that is what we want to build in computers. We want to create a process, and a process is a combination of many things, but there is a standard input and there is a standard output. That means you have to give it the input that it needs for that process, and it gets the definite output. So this is what we call as a method or a function or something like that, right? So we define processes in different languages. Like, for example, in Python, you call it dev. In Java, you call it a method. In JavaScript, you call it a function. So they all have different names for the same thing, process. All right. So I called it process because we are we don't want to be just limited to Python. We just want to understand how computer science works, and how they call it is their business. And tomorrow you'll have another language called Penang or something, and then they will have their own way of calling the process. It doesn't matter, as long as we understand that the fundamentally it's basically a process that requires an input, and it's got an output. So the input can be many forms. It can be one value, it can be an array, it can be a scalar, it can be multiple scalars, doesn't matter. And then the output also can be a value, can be an array, can be multiple values, multiple arrays, doesn't matter. But it is doing a fixed job. All right. One of the best things of being a good programmer is to think through your process so that I can use it multiple times. All right. So this is called reusable code, and that is where you should be heading to, becoming a good programmer who can think through all the processes, and that is when computing becomes really fun. All right. So let's continue on. The most basic logical operator is the if statement. Okay. You see, the English is not Shakespearean English. It's very, very rudimentary English. If a statement means it's a condition, whether the condition is fulfilled, then do what? So if statement, then else, if there is another condition, then we will check that condition and then do this. So you must see that it is stacked in a sequence. So you must really look into the logical expressions that we are teaching. It goes in a sequence. The first statement always has to be an if. Okay, it cannot be an else if. You cannot start off with an else if. You have to start with an if. Now, if that statement is not met, then it goes to the next else if. All right, and then so on. You can stack it with as many else ifs as possible. All right, and then the final last, absolute last statement has to be an else, and that's where it ends. So this is how we write an if else statement. Okay, so what I have done here is I have actually created an input. Okay, so you can see that I have used the method called input. Basically what it does is it asks you for a number. You can actually type a number. So I'm asking you, I'm trying to limit the number that you type between 1 and 10. So that's what it says here. Guess a number between 1 and 10. So that number you type is converted immediately to an integer. So that means some people, even if you tell them 1 to 9 or 1 to 10, they'll type S or T or whatever. To capture that error, I check if whether the number is an integer or not. So then I print out the number. Okay, the number that was printed out was guess a number, and it prints out the number was 5. So I keyed in the number 5, right? Then I've created statements, if else statements. Okay, so I am showing you immediately how it works so that you can slowly figure out later on how to design your if else statements again. So if now guess is now the variable that has been assigned the value 5 because I keyed in 5. So now it's going to check, is 5 less than or equal to 4? So if it's true, if it's true, then it's going to print low number. So you can see a lot of things are happening here. So I'll go very, very slowly. And this is one of the beauty about Python. You can put the semicolon, all right, and then followed by the activity you want it to perform. All right. So you see that if there's a semicolon, else if there's a semicolon, else also got semicolon. That's one of the ways of writing a method inside an if statement. Okay, so in other languages they have curly braces. Most languages have curly braces, but in in Python, it is a semicolon, okay, and it can be written in one line, okay, and you can also write it in multiple lines like this, all right, where you need to tab the row inside the if statement, so it comes inside here. So in Python we use tabs a lot, okay, we don't use curly braces, and that's one of the reasons why Python is so easy to learn, because it doesn't have all that overhead that you have with other languages, all right. So come back to here. So a lot of things are happening here. So you can see that this is what we call as the statement, okay. So this is a condition. That means it's checking whether guess, which is the value 5, okay, 5 because the user keyed in 5. So the user can also key in 3, all right. So it's making a decision whether guess is less than or equal to 4, and then print low number. Now we have another condition where if it's greater than 4 and less than 8, then we are saying it's a lucky number. If it's greater than 8, then it will go under the else condition. So I hope you understand how we've created like a little pyramid, where if it's less than or equal to 4, it's a low number. Now you can see guess here is greater than 4. I didn't put guess equal to 4. Okay, if I put guess equal to 4, it will already be captured here. It will bypass this, so it will never capture this, all right. But here I put guess greater than 4, so guess has to be 5, because if it's not 4, it's not equal to 4, all right. So if it's 5, only 5 is greater than 4. And you can see here I'm using plain English, and I'm not using like some programming languages uses the ampersand, the ampersand sign. But in Python, it's so easy. You can use ampersand. You can also use and as a joining operator. So we will talk about ands in a while. But I just wanted to show that, or I can even split this up as 2 lines. So this is something that you should try. Split it up as a new else if, and then create a new line. So this code that you have here is free for you to play with and massage it. I want you to understand how if else and else if statements work, because we will be using it a lot everywhere, all right. So this is how you construct a single line operator using if statement followed by a semicolon followed by the function that you want it to perform. If you have a lot of functions that you want it to perform and you can't put it in one line, you can use the tab function to do the same thing, all right. So you can see here it gets more, there's more messages that I'm printing like lucky number, guess a higher number. I'm giving a clue, and I am showing that, oh, you guessed it right, giving a little bit more messages. So therefore you can see the structure doesn't change, all right. The structure is what is very, very important, all right. So now since you understand if statements, okay, now let's look at how to construct an if statement. So I'm going to go ahead and open this in my Colab. So when I run this input here will cause it to ask, see, guess a number between 1 and 10. So I can put 7. No, I put 9. Okay, and I hit enter. So you can actually try it. You can hit 9. Now we will. So now that the number 9 has been associated to the variable guess. Okay, so guess is now storing the value 9. So you can see when you mouse over, it's actually telling you integer guess equals 9. All right, then when you run this, it will print the value that it's associated. Okay, so you can go ahead and change all of these things and now create your own messages and create your own if statements. I hope this is understandable. Okay. Now, so this is another example that you can try, and so I think it's quite straightforward. Now let's look at the operators that we have. Now, it's important for you to know the type. That means if it's an integer type or if it's a float type or any sort of number, these are the operations that we can perform on it. For example, we can do the plus, minus, divide, divides, same thing. Then we have the mode. Okay, I hope you know what is the mode, or we call it the modulus. All right, and then we have the other one, which is the power 2. All right, so you can say 3 to the power of 2 equals 9. So this is how Python language handles. Most of it is about the same for most languages. Okay, and these are called mathematical operators. So mathematical operators work only on integers. Okay, but you can use but plus in a string means something else. So as you go, you will find that they try to reuse the same operators again for different types. Be careful about that, because this is a mathematical operator. So when you're talking about integers and you want to add two integers, you use the plus. But you can also use the plus to concatenate or join two strings together. All right, you can also use plus. All right, so it's just a matter of the type that defines what the operator does, the symbol does. So try to have a very light-footed view about these operators, because they are very, very specific. So when you learn it, try to practice why these operators work in this particular way for this type of variable and not for another type of variable. So this is very language specific. Okay. And like I mentioned, Python is a very high level language. It tries to do a lot for you beforehand. Okay. Then we have the conditional operators. We have the less than, we have the so you always, this is how my mother taught me. Less than means that you keep your mouth closed. So it's always small when you read from left to right. So if you want more, if it's greater, then it has to be bigger. So that's less than, and then you have greater than, and then in between you have the less than or equal to. So it is exactly how we say it, less than or equal to. So that is the symbol for less than or equal to, or this is the symbol for greater than or equal to. All right, so you must always remember that the symbol comes before the equal sign. All right, so this is called the greater than operator, greater than or equal to operator, and this is the less than or equal to operator. Then we have two other operators. One is double equal sign. So equal sign, we learned the last time, was assignment, correct? Now double equal sign means it's a comparator. It's comparing two values, whether it is equal or not. So double equal sign is an operator, single equal sign is an assignment. All right, so you can see how we kind of reuse the operators for different purposes, right? So there's also the third equal sign. There are three equal signs. Okay, so that one is another level of check, whether it is exactly the same type, same size, same length, everything is the same. All right, so we will get to that when we get there. So you have the equal sign, and then you have the not equal sign. So the exclamation mark means it's not equal to. So you can see I've given some examples after it. So if 3 is less than 2, so this should be false, isn't it? Okay, so there's a mistake here. This 3 is not less than 2, so this should be false. Is 3 less than or equal to 2? False. 3 greater than 2 true. So this one is actually wrong. I should change this. All right. So this is conditional operators. And then we have uh, uh, logical operators. Okay, so this if then else is also considered as a is actually called a logical operator because it's making a logical decision. But on top of that, we have and, or, not, and XOR. So so I hope let me start with and first because that's the easiest to understand. Now, the easier way to learn this is try to look at the pattern. Okay, don't focus on trying to memorize each line. Okay, now what is unique about and is that only if both are true, it's true. Otherwise, it's all false. Okay, that's and. So and is very strict. It's like a very strict teacher. Only if the whole class pass, then the whole class can pass. You know, that sort of a thing. But or is a bit more flexible. That means as long as one is true, then it's true. So you can see they work in opposition, except that when both cases are true, both also and or are the same. Does it make sense? So look at it from that pattern perspective rather than trying to fixate on, oh, I need to memorize everything. No, it doesn't work like that. Try to look at it. So when you want something to be true for an AND case, both also must be true, then your response will be, your final condition will be true. The same for OR. If any one of it is true, it doesn't matter, even both, then your output is true. Now, how is XOR different? You can see that you must have in opposition, that means it must create an X. So only if one of it is true and the other one has to be false, then your output is true. Okay, so this is the difference between XOR and AND. So you can see that if XOR is in between and OR, okay, if both are true, it gives you a 0. If both are false, it gives you a 0. So it has to be different. All right. So having known this, then we go to the NOT. So the NOT is just the opposite. So we can now do pretty much any sort of logical operation with these 4 operators. All right. So this is the fundamental decision-making process that you need to build into your program. And this is how we define NOT, AND, OR, and XOR. When I mean 0 and 1, that means it's the condition of X is actually false. The condition, because these are 2 conditions. Okay, this can be condition 1, this can be condition 2. When I join the conditions together, this is the output I'm going to get if I join it with an AND and an OR. So if I were to show some examples later, you will see that it's what is that? It is actually joining 2 conditions. If we go back to our problem here, you can see there's only 1 condition here. So when I have 2 conditions is when I need a logical operator in between. So logical operators actually depend on some other decision and it combines with some other decision to produce the 3rd decision. All right. So that is why we use NOT, AND, OR, and XOR. So the easiest way to remember this is AND only works when everything is true, OR works when anyone is true, XOR only works if they are in opposition, and NOT is the opposite of the input. So with this amazing thing, these 4 different logical operators will allow us to solve all the problems in the world. I'm not kidding. Of course, something that can be reduced to a computer. Okay, so that's how we do. And then I just put this in here for you to kind of think about it, because as far as the computer is concerned, it only knows the bits. Okay, so we can even go down to the bit level and check and do an and a NOR. All right. So in actual fact, whatever we write here as a if statement or a less than or greater than or whatever is actually managed at the bit level. Okay, but we don't have to worry about it because the computer is taking care of all of this for us. Okay, so so that is this is what the computer does. So later on, when you do a degree in computer science, you'll be learning about bitwise operations. That means when you move the bit one place or two places, there is a lot of binary logic that kicks in. All right, so we don't want to go in there right now because this is more for you to know that you don't know, so it's important that there are things that you need to learn, and it's more advanced, and at this point you do not have to operate it at this level, but if you want to, there's a lot of information on the internet for you to learn how to do this. But then there's some basic knowledge you would need, which is binary logic, how to count in zeros and ones. So that is important before we get onto this bitwise operation. Okay. So I've created some operators here for you. All right, and I want you to just play with this and create more operators and make this knowledge your own. That means you now understand how an AND operation works, how an XOR works, how a NOT works, and all those things will allow you to improve your logical thinking. All right, so this is not some mumbo jumbo. It's very, very, very logical. If 3 is greater than 2, that means 3 is greater than 2. Don't worry about what people send you SMSs, where 2 plus 2 is 5 and all of that stuff. It doesn't work. This is pure logic. So you need to understand how to convert whatever problem you have to a logical operator. So a bunch of logical, so it's the logical operators at the end of the day that is actually doing all the work in a process. All right. Okay, so so I leave this to you to kind of expand on it, because it's a very interesting topic, because in the assignment you're going to solve a problem. Okay, in the problem solving you would need to create your own if else statements. Okay, now I don't want to go too far ahead. All right, the next topic is actually loops. Okay, why I'm talking about loops is that, just to give you an introduction, if I were to go back to my lesson number 3, which is the next class, okay, I'm very excited about this class because we're going to be playing with loops. We're going to play with numbers. We're going to play with your times table. And I'm going to show you that the numbers actually repeat themselves. And what we're going to look at is the patterns these numbers create. Remember, I told you, don't memorize, try to understand the patterns. So there we will cover more about loops. And of course, it gets a bit complicated, but then because the formatting is not correct, but then once you see it, when you run it for yourself, you will see how the patterns actually formulate, fall in place. So I will keep that for next week. But before we go there, I want you to play around with for loops. Okay, I want you to know how to create a loop. For example, say for example, I created a number that I assigned a value 100 to the variable numbers, and then I created a range, and I printed out if I is equal to 50, then print the value of I. All right, so it printed out 50. All right, so this is a very easy way of you trying to get comfortable with numbers. So range is an internal Python function that actually creates an array for you automatically. Okay, so let's just try it out. And I would like you to also try it out while you are, I shouldn't have clicked on that, while you are listening to me, because this is supposed to be an interactive session. So we can reassign numbers to, let's say, 5, okay, and then for I in. So you see, this is called a condition or expression, okay, for in range, and we will be using range a lot. We don't forget to put the semicolon at the end, hit enter. You see, automatically it's already put in the tab for you. That means whatever that comes inside it. Now we'll put in an if statement. All right, we don't have to put the brackets. We can just say I is the value that is going to be contained by the iterator. So let's just do something very simple like this. Okay, so if I did this, you can see that it will print I 5 times. Very easy, right? So now we can improve on this. So we can say that if I, and we remember the modulus sign. Okay, if I equals to 2, then we shall say equals 0. That means when I divide I by 2 and I get a value of 0, then I will say I is an what number? Even. All right. Else what? Print I is an odd number. All right. So let's try it out. You see, oh, 0 is not an even number. So you can see how easily we can. Now, we do not want to start with 0, so we can actually put 1, comma. So it's like I told you, right? You can have 3. So when you see the word, the function range has got a start value, has got a stop value, or you can put in the step. All right. So I can run it again. So you can see that now it starts off from 0. All right. And I can also do a step. Let's say if I wanted to do 12 and then I wanted to step 2, that it will only print out the odd numbers because I'm stepping, right? So if I wanted to start from if I wanted to do 11, yeah, so because I'm stepping by 2 and starting from 1, so if I started from 2, it will be all even numbers. All right, so this is beautiful. I mean, you can play with it. You can now start creating loops. I'm creating a very simple, very basic loop for you to start understanding loops. So once you understand how to create a loop and combine it with logical operators, there's a lot we can do. There's a lot we can do. All right, we can handle. You must understand very quickly. We are going to go from standard 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to arrays. We're going to handle large amounts of values, so we are not going to be limited by just the number system. Okay, so be prepared to take this understanding or this learning a little further. So now you can see that with this method range, you can do a lot of things. Okay, so whenever we want to create a array, all right, the fastest way is to create using range. Okay, so what I also want to tell you is that you can create a range. You can also, you remember I told you that a string is actually an array. So you can also do this. So you can see how it's printed out all the characters based on this string. So this is the beauty of Python. If you want to do this in Java, it is quite cumbersome. You need to convert it to an array, and then you got to specifically tell it hey, this is not a string, it's actually an array of alphabets, then it does the necessary. So the same thing that we can do. All right, so you can go on to create more stuff, right? Remember I told you about Gauss, right? So Gauss was able to be able to count one was able to count from 1 to 100 in no time. So let's do that. So let's now create a variable. So count. Okay, we set it to 0. Then we have for I in range. Okay, we want to count. Okay, so we just create a limit of 100. All right, and then put the limit here. All right, and then we say that count is, now this is a new operator. Okay, it's combining the assignment with the plus. That means if I was 1, it will add the next number to it. So I can just put I here. All right, and then I can, sorry, and then I can do count. All right, let's see whether this works. Okay, so it went from sorry, it should be this way. Now there is a problem here. Actually, it should be it went from 0 to 99. So I need to add one more here. So Gauss was able to do this in 5 seconds because you will see that if he actually saw the numbers in an array, and in one of the classes I'll show you how to use algebra to do this, and it's much faster. You're even you can even beat a computer in finding the answer. Okay, so I'm going to copy this. Sorry. I'm going to copy this. And this time I'm going to put it as 1,000. All right. You see, there is actually, the numbers are actually starting to make sense. This 50, 50, 50, 55, 0 starts to reappear. Now, this is true. When if we understand this pattern right here, you will notice that I can count till 1,000,000 or even 1,000,000,000 or whatever. So this is the patterns that I will introduce to you little by little, and it's easy, and it's very easy to see with a computer like this. And you can start playing, and this is just plus. Okay, you can do multiplication, you can do various other things with numbers. So the idea behind this lesson is for you to start playing around with logical operators and loops. Okay, once you understand these two things, the whole ocean of computing and mathematics becomes a joy. It's like looking at a painting and observing the patterns and the colors and how they all fit together. All right, so you can see right now there is a pattern, but I won't dive into it right now. I will slowly take you through it. All right. So you have a few things that you can do up here to play around with the loops and the conditional operators and so on and so forth. And then we have the assignment. Okay, the assignment, to my view, is very, very easy. All right, but it would require some thinking on your side. Okay, so we want to develop critical thinking. That means you are able to logically, what is critical thinking is logically arrive at some resolve or some result. That is critical thinking, and having this ability will make you a lot more logical in your approach. You're not easily convinced by assumptions that are not valid, and so on and so forth. So this is a practice. This is the practice that you need to start now. Okay.